Hello again. In this recording, I will solve a problem on the projectile motion. So the question statement is as, so the golf ball is hit with an initial velocity of 80 feet per second and it lands on the position B. The question says that what is the speed at B and also the time of flight from A to B. So this is position A. The golf goes and lands this way. Position B. And then if I show the path, the distance, okay, and then this distance has okay and then here we have the 10 degrees, let me draw it again. Okay, then the angles, if I show here, this one is the 10 degrees, and then here also it shows the initial velocity as 80 feet per second, and this one is 45 degrees. Okay, and then the question is that, let me just show it separately. This one is the initial velocity, and then we have the x component of it, and then we have the y component of it. And similarly here you can see the d distance is inclined, and then this is the x component of d distance, and this one is the y component of the d distance. Okay, so you have to make sure that you understand that our x-axis is this one. It is not the same as the d, and then our y-axis is this one. Okay, the x-axis is different than d, and this is a very important point. Okay, with this in mind, let's solve the problem. And then first I will start with the velocity components, and then to find the velocities at point B, I know that the x velocity doesn't change. Vx is constant. So if I know the Vx as an initial point, then I know that that will be equal to Vx at point B. Because when it lands on point B, the golf ball moves in this way as well as in that way. Okay, because if I zoom it out, show it separately here, and then this is point B. Okay, at point B, the golf ball moves that way. Okay, and then if it moves that way, it has an x component and it has the y component. At P, and then V at P has the x, and the V has the y component as well. Okay, then let's try to find first the initial component of x, and this is just a simple trigonometry. And then here it is 55 degrees because 45 and then 10, and then Vx B will be initial V with the cosine of 55 degrees. And then we can also find the initial y because we will need it in the next formulas. That will be that V initial into sine 55. Okay, these are just simple trigonometries. Then cosine, you take the adjacent, and sine take the opposite one. and then we can solve it in Excel. I will start with the 55 degrees and then convert it into radians. You can see that radians, let me show you, converts degrees to radians. Okay, and then 55. Okay, the first one is the initial velocity, which is 80 feet per second, times the cosine of 55. And then again 80 times sine of 55. Okay. The first one is the cosine and the second one is the sine. So if you take the cosine, this one will be the x component, and that is equal to 45.89 feet per second. If you take the y component, it will be that 65.5 meters per second. Feet per second. Okay, so let's move on. And then the question asks about the velocity at b, and then the time of flight, and then etc. So velocity at b as a y component will be equal to, if I use the formulas that I have, initial velocity minus gt. That v initial minus the g and then t. And then initial velocity, I know it is in y component, it is 65.5. And the gravitational acceleration is 32.2, and then times time. So I have one unknown and I have one equation. Okay, so what it means is that, sorry, I have two unknowns. Sorry, my friends. Two unknowns because I don't have the velocity at point B and I don't have the time. So two unknowns, one equation. So what it means is that I need additional equation to relate either time or the velocity. And then I will go with the time because it's easier. And then to go with the time, but you can go with the velocity with the b as well. Just it is not about which one you start, it's about to finding an equation. So let me add it. So it's about the finding an additional equation to solve the problem. So I will go with the t. You can go with the vy, it's up to you. So okay, so and then what I will do is that I will use the x component because this is what I always like. Very simple. So I will say that the distance it travels in x direction, I will call this one as dx, and this one I will call as dy. Okay, dx is equal to, if you just similar trigonometry, the adjacent side, but that will be the d of the cosine 10 degrees. Okay, and that's equal to, if I go back to formulas here, in x direction, the distance is initial velocity plus the velocity times the time t. So initial position, sorry. And the initial position in our case, it is 0 plus the initial velocity in x direction is 45.89 times t. Okay, so what happened? So the result is I added one equation but I have one more new unknown. So what's the result? I have 3 unknowns, but I have 2 equations. What are those 3 unknowns? The velocity at point B, the time, and the distance. Okay, so I need one more equation. Okay, then one more equation I will take for the distance d, but now I will go with the y direction distance and then try to relate and then find the unknown. So let's do that. The y direction is that initial y plus the y initial velocity time and then the acceleration half into t squared. Okay, so dy, which equal to d sine 10, and that's equal to initial y is 0 plus the initial y velocity, which is 65.5, times the time t minus half 32.2, this is g, and then times the t squared. And then instead of t squared value here, what I can do is that I can say that from here that t is d cosine 10 by 48.89. Okay, so I will just say that instead of t squared, I will say that d cosine 10 by 48.989 squared. Okay, so now you can see there is no unknown. I mean, new unknown. There are unknowns, but they are not new. So I just balance the number of equations with the number of unknowns. So I have 3 unknowns, 3 equations. So what means is that I can solve the problem easily. So similarly here, I will say that this t is equal to d cosine 10 by 45.89. I will use Excel again to solve the problem, but let me stop the recording here and then continue in the next recording.